Hello everyone and welcome to Linux Forensics here at Pen Tester Academy. In this video, we're going to continue our discussion of file system plugins with Volatility. And in particular, we're going to look at ways that you can actually recover some of these file systems that are based on the memory, or at least the parts that are cached. So how do you do that? Well, it's pretty easy. As always, we'll use our favorite plugin. So once again, this guy right here, volpy -- profile and -f, the name of our Lime file. So I'll say VPA Linux, and now I want to recover file system. Unfortunately, this is an all or nothing kind of deal where you get the entire cached file system from memory. You can't just say, I only want part of it. So I want to go ahead and dump the file systems, all of them that are cached. And I first need to make a directory. So I'll make a directory temp, my cache fs. And now I'm going to run volatility, VPA, Linux, recover, file system, -D. I could also use -- dump. And I want to go to tmp my cache fs. And as we can see in my case here, volatility nicely fell down. Came up with an error message and some of the Python code. So what happened? Well, it's one of those things where memory analysis is very fickle. So for whatever reason, this plugin, maybe it doesn't like the particular kernel that's being used here. If you look at what Volatility claims to support, they claim to support through 3.14. It's actually a 3.16 kernel. Sorry, that's the way it goes sometimes when it comes to using tools like this. Now, perhaps by the time you're watching this video, that might have changed and this might work for you successfully. So interestingly enough, we were able to run volatility and enumerate over our files, but we weren't able to dump the file system. Now, there are some other things we can try. There is a module in volatility that allows you to find files. And not surprisingly, it's called find file. So if I want to find a file and optionally extract its contents, I can use find file. Now, unfortunately, this doesn't seem to support wildcards, but I can use the information I got previously from my enumerate files, and I can use that in order to run volatility on a specific file. So in this case, I'm going to run it on the Xingqi bind shell port file in the temp directory. And here it's telling me the inode number and the inode address and the file path. If I want to get the contents of this file, how do I do that? Well, I use find file again, but this time I will give it -I, and I will give it my address for my inode. You might say, why not the inode number? Well, that's not the way it works. That's the answer. You might say, why does it work this way? It is a memory analysis tool after all, so it's not surprising that it wants the address. I can give it a place to output -O, and I'll actually put it in the same place. I'll put it under temp Xingqi bind shell. And this would actually work better for me if I used a capital O. And that completes. Now if I cat temp Xingqi bind shell port, sure enough, it tells me, yep, it's using port 7777. Not surprising. So what are some other things that I can do here. So we've already seen that we can list files. We can even recover files using find file. It's not a one-step process, but you can do it at all. It's still pretty cool. You can also do things such as create a timeline. And how do you create a timeline? Recall when we talked about the sleuth kit, we talked about body files and how you can create a body file. So let's do that. And the plugin for that is actually called Linux Dentry Cache. And this will create a body file. So if I do VPA Linux Dentry Cache and I redirect that to a file, call it body.txt, then I should have a file. And it looks like once again we've gotten bit by a little volatility problem, which hopefully by the time you're watching this, maybe someone will have fixed this issue. It appears to not really like some of the more recent Linux kernels. So again, what's the lesson here? We've had a couple of issues in this video with volatility not doing what we wanted, but fortunately, in many cases, we can get this information somewhere else. We did some videos earlier where we looked at building timelines from the actual file systems themselves. And of course, that can give you a much bigger picture and a much more accurate picture, unless, of course, you're dealing with file systems that are temporary and only in memory. In that case, Volatility does provide us the ability to actually find those files and extract their contents, which is something that we couldn't necessarily do with normal file system forensics. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon.